Okay, we're going to do part 2 now of Advent of Code. Part 2 says for some reason the Seaport's computer system still can't communicate with your Fairies docking program. It must be version 2 of the decoder chip. Oops. Version 2 decoder chip doesn't modify the values being written at all. Instead, it acts as a memory address decoder. Immediately before a value is written to memory, each bit in the bit mask course modifies the corresponding bit of the destination memory address. If the bit mask bit is 0, the corresponding address bit is unchanged. If the bitmap bit is 1, the corresponding memory address bit is overridden with 1. If it's X, the corresponding memory address bit is floating. A floating bit is not connected to anything and instead fluctuates unpredictably. In practice, this means that floating bits will take all possible values, potentially causing many memory addresses to be written all at once. Okay, so for example, consider the following program, a mask that has some X's in it, memory 42. When this program goes to write memory address 42, it first applies the bit mask. So the memory address is 42, which is shown there on the top. There's the bit mask there, x1001x, and then we're going to apply that, and we get X at the end. Okay, so it's keeping the X's there. If we've got 1, we keep that. If we got 0, we go to Z. So if it's 1, the corresponding memory bit is overridden. If it's 0, it's the same. So we've got a 0, it's 1, okay, and a 0, 0. Okay, after applying the mask, 4 bits are overwritten. Okay. 3 of which are different and 2 are floating. Floating bits take on every possible combination of values with 2 floating bits. 4 actual memory addresses are written. Okay, so put in 0s, 1s, and 2s for each of those locations. Next, the program is about to write to memory address 26 with a different bit mask. Right, let's see what happened. Floating points take on every possible combination. Okay. Four bits are overwritten, 3 of which are different, and 2 of which are floating. Floating bits take on every possible combination of values. Okay. Next, the program is about to write memory address 26 with a different bit mask. Okay. This results in 3 floating bits causing writes to 8 memory locations. The entire 36 space still initialized to value 0. And you still need to sum all the values left at the end of the program. In this example, the sum is 208. So we're writing all of those memory locations. We're writing that value to each of those memory locations. Okay, execute the initialization using the emulator for version 2. What does the sum of all the values left in the memory after it complete to? Okay. So I think our parser will still work because we're using the same input. So I think our parser is okay. We need some new logic for applying that in part 2. Def, I'm going to say apply mask P2. We're going to have a mask and an amount. Okay, so here is our mask. So we're going to write 100 to those 3 locations. So we write to 26. So we write to 26, 27, 58, and 59 with 100. Then we write to 26, 27, okay, and all these other ones with 1, and we overwrite 2 of those, so we should get like 207. Okay. I think this is somewhat making sense. So let's just do the apply mask logic here. So apply mask in part 2. So a 0 unchanged, a 1 is overwritten, goes to 1, and then x is floating. So what do we want this apply mask to return? We want it to return all the memory locations. I think that's what we want to return. Returns memory locations. And so this is actually a location. And so if we did this mask here, well, let me just write this out here as a doc test. So this is going to be apply mask P2, and the mask is going to be x1001x, and if we apply that to 42, then, and we put this into a list, then the values of that should be 26, 27, 58, and 59. So that should be this 26, 27, 58, and 59. Okay, so that's what I'm going to try and get here. So let's see here. Up above, I had this logic here. Maybe I'll just copy this and steal it. A sort of boilerplate for this. Okay, so if 1 in mask, then we're going to keep a 1 where the 1 is. So we're going to take all of our values, and so what we can do for the 1 mask is we can replace x with 0, and we can replace 0 with 0, which it already is, and then we just OR it with the 1 mask. Okay, and so that should do that. Up above here, 1 changes to 1. So that logic is right for the 1. Okay, so part 2, 0 is unchanged. So if 0's in there, we don't do anything with it, so we just leave it. We ignore 0's. Okay, I think we ignore 0's. Let me just look at our program up here. Okay, so here we've got some 0's. 1, 0, x, 0, 0, 0. So this right here is a 0 where we have a 1, and it doesn't change that result. Okay. And then we've got our x's in here, so I guess we can get rid of that. So we've got our x's in there. What do we want to do with our x's? We want to replace each of them with a 0 and a 1 and get all of those values. So okay, so what we can do is we can count the number of x's. We can say num x's, and I'm going to say mask.count x. And then we're going to use the combinations module here to make all the combinations for the number of x's for ones and zeros. So I'm going to, I believe that's in itertools, import itertools. And I'm going to say for vals in itertools.combinations, and okay, so itertools.combinations is combinations in itertools, or is it? Let's just double check here. Dir iter tools. Yeah. Help itertools.combinations. Iterable and R. So I think we want combinations 0, 1, and the length is num x's. And then what we're going to do is we're going to say new mask is equal to mask. Is it new mask or is there a one mask? It's our one mask. We're going to say one mask. And we're going to say, what are we going to do? We're going to replace every x with, we're going to replace every x with the combinations here. So let's see if I can do this. This might be a little funky here. I can say one mask dot replace, and I'm going to replace an x with that. This will give me a string, and then on that I'm going to call a format, and then I'm going to take my vals and plop that in there. Okay, this will be my new mask. And then what do I do with my new mask? I just yield that. Okay, I think that's it. I'm just gonna, whoops. Now if I don't have any combinations here, if I don't have any x's, that might be problematic. Okay, let's push this up the hill, see what happens. And I'm going to do doc test. One failed. What's failing here? Val referenced before. Okay, line 62. And this is not val, but it is loc. So maybe I'll just change this loc to val. Okay, and I did not get what I wanted here because I got the mask, and then I need to convert the mask, which is a string, to an int base 2. I'm just going to do a print in here, num x's, and I'm going to print my mask, and it's my one mask. Okay, and why did I replace x with 0 here for my one mask? I don't want to do that. I want to replace okay, so I've got, let's look at their problem here. X1001X in memory location 42, I'm saying that's 100. And so what I'm going to do is I'm going to take that mask and apply it to 42. And I should get X110. Okay, so I need to mask wherever I have x's in there, I need to leave them. And wherever I have ones, I need to replace them. Oh boy. Okay, so can I do the four? I've got 42. And then I've got this X, my mask here. A 1 and a 0. Yeah, my problem is I want to replace the 1s, but I don't want to replace the x's. I want to take my address, I want to apply my mask, but I want to keep the x's in there. So how can I do that? Well, I've got Well, I could get the positions of all the x's, and then I could pull them out again that way. Let's see. Let's see. I want to keep those x's there. This is kind of a pain because I kind of need to pull the x's out, do some binary operations, and then put the x's back in. Just gonna look at my input here. I mean, I'm gonna see if I can do some silly hack. I guess. Okay, so the mask is that whole long thing there. Okay. Okay, so I guess we'll just sort of hack this out here. So the x positions, we call that x pos, is equal to, and I'm going to just say it's a list, and I'm going to enumerate. It's going to be starting at 0. I'm going to say enumerate. It's going to be I for I car in enumerate our mask if car equals x. Okay, so there's our x positions. And then we can do our mask here. And we don't want to replace that. We don't want to replace this with our one mask. Basically, we're going to take our one mask and our value, and we're going to, if it's a 0, we're going to keep the same. If it's 1, we're going to go to a 1. And so ORing that would do that. And then x is going to be floating. So we don't need to make a one mask here. We just need a mask here. And then at this point, we've got our mask. Well, actually we do need to make our one mask. And then we'll use our mask again. So here's our result. So we need to take our result and we need to put, we need to convert this to binary. And we need to put the x's back into it. Okay. So let's convert it back to binary. And when I mean binary, we're going to convert it back to a binary string. So I'm going to say amount or val bin stir is equal to, and I'm going to say binary of, not binary. So let me just try this out here. Python. We'll do like, if I've got bin of like 57. Okay, there's that. Let's look at the help of bin. I don't want that 0b at the end. So I guess I could pull off the first two and then I could left pad it. So it's 36 long. So let's see if we can do this. Help. Dir of a string here. So what's left pad? I think it's zfill. Help, zfill. Pad a string with zeros on the left to the length. So we're going to say like bin 57, and we're going to pull off the first two characters. That will give us, sorry, we want to start after the first two characters and go to the end, and then we're going to zfill 36. Okay, so that is our string. So it's bin, whoops, bin of our val. I go from 2 to the end, zfill 36. And then at each x position, we need to update that, which is sort of a pain. So what we can do is we can convert this into a list. Okay, once we have it as a list, then we can update the values there. We call this the val bins, and then I'm going to say val bins for I in x pos, val bins I equals x, and then I'm going to say val bin stir. This is kind of hacky, but I'm going to take it is equal to an empty string. And we're going to join our val bins. Okay, and then at this point, I can say my mask is equal to this val bin stir. Okay, I'm going to push this back up the hill and see what happens now. Okay, and I don't have enum in here because this needs to be enumerate. Okay, and we got, that's not right. So it's not one mask here, it's mask. So we got two of those, and we're going to do a mask.replace. Let's just print, okay, we're printing out the mask here. So there's our mask. Is that right? No, that's not right, because our apply mask here, when it counts the x's on our mask, we need to left pad the mask here. So I'm going to say mask equals mask zfill 36. Make sure that it's left padded here. Okay, so now we've got two. I've got x1101x. Let's see if that's what the documentation has. x1101x. Okay, that is correct. And we should have, okay, so we now need the combinations of all these values here. Just going to say print vals. Zero, one. And is it combinations or permutations? Maybe it's permutations that we need. Let me pull up itertools here. Permutations, and we're going to say 0 and 1, and we want 4 of those. Combinations. Do I have to say 0, 0, 1, 1? Those are all the options? No? What am I missing? All the different combinations of length 2 of 0 and 1. Should be 0, 0, 0, 1, 1, 0, and 1, 1. Is it permutations? 0, 1? No? What am I missing? Missing something here. Okay, so I mean, is it does it support nested things like take 0 or 1? No, that's going to be like yeah, so it should be permutations. Range 2, so we want range 2 and how many there are. Permutations. Let's try range 2 instead of 0, 1 here. So here's 0, 1. Let's do range of 2. Why isn't 0, 0 in there? Because it doesn't let repeats. What am I missing? Okay. Okay. I mean, I'm gonna go sit on this because I'm not getting anywhere. But I believe if I just get the permutations in here, then this one will solve itself pretty easy. But since I'm spinning my wheels, I'm going to take a break and then I'll come back to it. So we'll see you soon.